Okay, so by now we have smoothened the data set. That means we have taken now uh, seasonality factor and the irregularity factor. So when it comes to your lecture slides, now we are in step 9. So now we have to come up with the seasonal component and irregular component. So here next to your centered moving average, we are going to come up with seasonal component and irregular component. So here I'm going to subscript these t values because it's going to be seasonal component for the time period. So to subscript t and here t again, go here and going to subscript. Okay. So in order to come up with the seasonality and irregularity, that means out of these cells to which extent is ST and IT or seasonality and irregularity, what you have to, the logic is that you have to divide. So I'll remove this. I'll leave only smoothly. So the logic is that to come up with this column, you are going to divide the sales values by the centered moving average values. So the reason is because I told you in centered moving average, what we have done is that we have smoothened the data. That means we have taken out the seasonal component and irregularity component, and we have only the trend component here now. So when you divide the sales values by the centered moving average values, you are getting the value for ST and IT. So here I name the sales value as YT because the notation for sales is Y. So I'll subscript the T. So here, the reason why we say that we can derive the ST and IT values by dividing sales values from centered moving average values is basically because of the multiplicative model. So about the multiplicative model, you can read it in the slide number 19. Actually, we have covered the theory when it comes to your business statistics module also. So in multiplicative model, what is said is that the sales value is equals to seasonal component into irregularity component into trend component. So in order to come up with this S and I, ST and IT, so what you have to do is you have to divide Y by T, trend. So trend we have centered moving averages here, sales values you have it here. So in order to come up with ST and YT, you have to divide these values from the correspondent centered moving average. So when you divide it, you are getting the seasonality and irregularity components here. So I'm not going to have the decimal points for this number of decimal points. We'll have it only for 2 decimal points. Okay, so I have taken it for 2 decimal points by choosing this particular option. All right, so now we have come up with the seasonality and irregularity components. Is it clear for everyone? So based on the multiplicative model, we know that sales values is equal to seasonality into irregularity into trend. So here we have come up with the trend values. Here we have the sales value. So when you divide sales values by the centered moving average or the trend, you are getting this SI. Is it clear? So now there is something that you should know. So you should be able to interpret the values that you have derived here. So if you look at this value 1.10, what it means is that so you have this in correspondent to year 1 quarter 3. Look at year 1 quarter 3. So when you look at year 1 quarter 3 in the time series plot, you have that particular plot 5.5 here, and the 1.10 plot over here. So what is meant by 1.10 is that this particular uh, the seasonal factor and the irregularity factor is 10% above the baseline. Is it clear? So what is meant here is that what is interpreted by this 1.10 is that always this 1 is the standard. So if it is 1.10, that means the seasonality and irregularity factor, the change is there above the baseline. So the baseline is the centered moving average. So we'll name it as baseline, the trend. So 10% of this 10% change is done to the trend line, 10% increment of change, the variation is done to the trend line because of the seasonality and irregularity factor. When you look at a value like 0.97, that means 1 minus 0.97 is 0.03. So this is in correspondent to year 2, quarter 1. So when you look at, rather than looking at this value, we look at this 0.84, which is below 1. So this is in correspondent to year 2, quarter 2. So when you look at this one, you all can see the because of the seasonality and irregularity factor, the trend line, the variation has caused by the deduction of the trend line is below the baseline 16%. So if 0.84, if it is 0.84, it's 1 minus 0.84 because it's below 1. So that means it's below the baseline, below the centered moving average line. This is caused because of the seasonality and irregularity. Now what we are going to do next is that we are going to come up with the we are going to remove the irregularity factor and we are going to come up with the seasonality factor here in the next column. So I'll subscript because I would be using the same notations. So in order to come up with the seasonality, you have to come up with quarter and here also I'll subscript. So we have to come up with the seasonality for 4 quarters, 3 and 4. So this is how you can come up with the seasonality factor for the first quarter. This is easy. This method is easy if your data set is small, but if your data set is big, I'll let you know another technique. So here, if it is this data set that we are dealing with, in order to come up with the seasonality, if we are going to remove the irregularity, you have to take the average of, here we don't see any values in correspondent to year 1's quarter 1, but in correspondent to this there is a value, and in correspondent to year 3 quarter 1 this is the value, in correspondent to year 4 quarter 1 this is the value. So this is the seasonality factor for quarter 1. This we can do one by one only if only our data set is a small data set like this. But if we have taken the time series data over the past 20 years, doing this would be little bit complicated. So instead of doing this, following this technique, you can follow this particular technique. So square mark average if is the function. Average if, then the range goes from here to here, because this is the uh, this is the data set that we are going to take use of in order to come up with the, in order to find the average. So this is the range. The criteria is that average if criteria is here. So we have to find the average here if the quarter criteria is quarter one and the average range is from here to here. Is it clear? Wait. Okay, so here I made a small error. So average if is the function. Am I not getting it? Average if, so you can select it. First you have to select the range. So range is going to be, this is the range that you would look into. So this range has to be first for the first cell. If you are going to have the average here for the first quarter, then this is the criteria. Okay. And what is the average range? Average range is here. But you have to make sure this range, this particular range is correspondent to this particular range. So make sure that you are going to have in the same level. So lock it down. Okay, right? And tap it. So you are getting the same value that we have got before also. So when you drag it down without having the averages one by one, you can use this particular function. So it's the average if function. First, when you tab it, you get the, first we have to select the range. So this would be the range. And then the criteria is that out of this particular range, you are going to ask Excel to look at whether this is equivalent to this quarter. If it is this particular cell, so the quarter is 1. So if it is quarter 1, you have to average the values that are in correspondent to quarter 1, like 0.97, 0.92, and 0.91. After that, you have to get the average. Is it clear? Then when we drag it down, so here the criteria is different. What we are asking Excel to do is that first look into this particular range, then look into whether the particular range is equivalent to quarter 2. If it is 2, you have to average all the numbers that are in correspondent to quarter 2, like 0.84, 0.84, and 0.83. Is it clear? I hope it's clear for everyone. So that's how we can come up with the seasonality factor. We have got rid of the irregularity factor now. I hope it's clear. Okay, students. So now we have come up with the seasonality for each quarter. For all 4 quarters, we have come up with the seasonality. Now we have to take these values here. So taking these values here is very easy. You can either take copy and paste the values here. But rather than doing it, so one way is that you can first quarter is 0.93. So here year 2 first quarter also it's 0.93. Year 3 first quarter also it's 0.93. Then second quarter it's 0.84. So you can do this way, but if this you can do since the data set is small, but if you are going to deal with a relatively large number of data, relatively large number of data set, so huge data set, this would be very difficult. So what I recommend is the VLOOKUP function. So we have used the VLOOKUP function initially also. So it's VLOOKUP. So VLOOKUP value is that first they have to look into this value. And the table array is, this is the table. Okay, table array is this, but we have to make the table, we have to lock it. So by highlighting, when you click F4, the table is locked. And so you have to ask Excel to look at the, in the table, they have to look at the second column. Column index number is 2. So if, so what is the logic here? We have asked Excel to look up first this quarter. If this quarter, if then we have given the particular table, we have locked the table. In the table, so if here, if the value is 1, that means in correspondent to this table, we have asked Excel to look at the value that is in correspondent to quarter 1, and you are asking Excel to look at the second column of the table. That is why here we have put it as second column. Then we are asked to tell Excel, we are going to ask Excel if the value here is 1, you have to look into this one and take the value that is there in the second column here. So we would be choosing the false, exact match, exact match here. Check with the, look at here, see, you are getting the same value that you have got here. So drag it down. So here we again take it as 2 decimal points, because here also we have taken it as 2 decimal points. So I hope it's clear for you. Now we have got rid of the irregularity factor and we have come up with the seasonality factor. Now we have T and we have S. Okay. Okay, students. So now we have come up with the seasonality component. So what this means, what this value means is that when you look at this value, you can see it's year 1. We look at this value. So when you look at this value, it's 1.09. This is in correspondent to year 1, quarter 3. So what this means is that when compared with the baseline is this, the seasonality is 9% above the baseline. So when you look at year 1, quarter 4, the seasonality is 15% above the baseline. Baseline is the centered moving averages. So if you look at a value like 0.93, which is below 1, that simply means that here year 2, quarter 1. So if you look at, rather than looking at this, we'll look at year 2, quarter 2, here this value. So what this means is that this point. So this point, the seasonality is 0.16. That means 16% below the baseline. So you should know how to interpret these values. The next one is deseasonalizing the data. So in deseasonalizing, what you do is that you are going to divide the sales values from the seasonality. By doing so, you can come up with the seasonalizing column. That is the next step. So in order to do that, there's nothing much. It's dividing this value by seasonality. So you are going to drag it down. Now you have come up with this seasonalizing column. So here you have the deseasonalizing column. Okay, so I'm going to stop the video here, and by now what we have done, just recall what we have done, because you need to remember all these steps. So we never know, there would be a question from this when it comes to your final exam. So practice, practice, practice. Remember all the steps. I know it's difficult, but remember the steps. So first we have visualized the data set. Then we have come up with by using the moving averages technique, we have smoothened the data. Since it was taken an even number, we have found the moving averages. As a result, we have centered moving, we had to come up with the centered moving averages. So that is the baseline. Then we have uh, taken out the seasonality and irregularity by having considered this particular as a multiplicative model. So then after that, what we have done is that we have taken out the regularity, and here we have come up with the logical table, and we have taken the seasonality factor. After that, we have deseasonalized the data set. I hope what we have done up to this point is clear. If it is not clear, no problem. You can pause the video and uh, hear what I'm saying again and again, and concentrate as to what I'm explaining. Okay, so we'll meet in the next video. Okay, students, so now you are in part 5 of time series analysis video. So it's bit of, as I told you earlier also, this is bit of a lengthy lesson. So there are so many steps, so you have to follow them in a sequential manner. Now we are in step 10. So in step 10, we have already followed the step 10 when it comes to the practice question. So we have deseasonalized the data set. So in order to deseasonalize the data set, what we did was we have divided the cells with the seasonal component that we have derived. So now if you have been following the steps along with me, now you would have you would be having Excel. You would be having an Excel like this. Check whether you are getting this particular Excel. Okay, so now we are here. So the next step is, now we have derived, we have the seasonal component. We have got rid of the regularity. Now we are left with only the trend, because according to the, we have been following the multiplicative model. So I'm going to subscript it. So T. Okay, so according to the multiplicative model, y equals s into I into t. The reason is because we don't have any cyclical factors, because we have only the data for a limited time period, only for 4 years. So we have been following the multiplicative model. We have got rid of the regularity factor, and we have derived the seasonality, and now we have to come up with the trend component. So I subscript it. So this t, the subscript t, here also you have a subscript t that represents basically, here in the second step I told you to come up with a time code column. So by now, if you have been following the video, you should have derived, you should be having this column also. So if you have missed taking this column, now you can insert a new column and have your time codes like this. So now all cool. Now in order to derive the trend component, we are going to run a simple linear regression, taking deseasonalize this data set as our y, and taking this particular time codes as our x. So how can you run a simple regression? So I told you, we have already discussed as to how you can run a simple regression when it comes to Excel. So first you have to make this data analysis tool pack. On data menu, you have it on the right hand side, but this is not readily available. Make sure you enable it. Go to options, add-ins, and here you have to choose the Excel add-ins, go and here you can choose the data analysis tool pack. Since I have already made it available, I can see the data analysis tool pack on my data menu. So now I'm going to run a simple regression. Go to regression. So here I asked you to take this as your input Y range. So I'm selecting it along with the label. So the input X range is this. Since I have selected, for both X and Y, when I was selecting both X and Y ranges, I have selected the label. So I'm choosing labels. Now I am going to select the output range. That means where do I want the regression output. So I'm going to have it somewhere over here so that it won't be coming along with the data points that are already there. So I'm going to have my output over here. When I click OK, so now I have my regression output. Look at my regression output. So this is my regression output. So when you look at a regression, these are the key things that you have to look into. So normally we look at the r squared value. That means to which extent x variable is explaining the variation in the y variable. So it's cool. It's 91.51%. And the significance of the model is also okay because it's below 0.05. And when we look at the intercept and the p-value for the time code which we have taken as our x variable, the coefficient, so that also below 0.05, so that everything seems significant, model and the coefficient. So now we are going to run the regression over here. So equal, I'm going to come up with the regression model. Intercept is 5.05. So that's there in B442. So I'm going to, in my model, I have to make it a constant. So highlight it and click F4, or else you can put dollar marks at the beginning of the letter B and digit 42. So then plus, what is the coefficient? Here the coefficient you can see it's 0.14. So it's a positive coefficient. So this seems to be correct because when it comes to here the trend line, it's more of a the trend line over there. Okay, so now we have derived the regression output. Now I'm going to come up with the regression model here. It's equal. So what is the intercept? It's 5.09. So when I choose it, I'm getting the formula, the cell reference. So I'm going to make it constant. Otherwise, when I drag it down, the uh, cell reference might change. And plus, what is the coefficient? It's 0.14. That also I'm going to make it a constant. So plus, okay, this one also constant. Okay, into what is our independent variable? We have run the regression considering t as our x variable. So here, and so now we are done with the trend component. Also, I'm going to have it in the two decimal places. When you look at this regression model, since the you have got the coefficient for the time code as 0.14, it's positive. So when you look at the when you look at the chart, look at here the baseline, you all can see there is a positive slope. So that is further proved through the regression model, that regression output that we have derived also, since it seems to be a positive coefficient. I hope what we have done until here is clear for everyone. Okay, I hope what we have done until now was clear for you. Now we are going to forecast the future based on what we have been doing until now we have been doing a lot of work. So now it's time for us to forecast. So here in this point, what we actually did was we took out the seasonality and irregularity component, and here we have come up with the seasonality component, and here we have the trend component. So based on the multiplicative models, now we have got rid of this irregularity component, because irregularity component is different from one point to another in the real life situation. So here now to forecast, what you have to do is that you are going to multiply the seasonality by the trend component. So when you do that, you are getting the result. So these are the forecasted values. If we had forecasted based on this particular method for year 1 quarter 1, we would have got the forecasted value here as 4.89, but in the real life situation it has been 4.8. So when it comes to forecast is about future. So in what you have to do, what the intended objective is to forecast the values for forecast the sales values for the next four quarters in year 5. Year 5, let's have year 5, 1 2 3 4. Okay, so here we'll drag this down. So now we have everything we need, and we'll drag this down also, because here we have derived this trend component based on the simple linear regression model. So when you drag it down, since we have entered the time code here, now you would be automatically getting the seasonality and trend components with respected to year 5 4 quarters. Now you can forecast the values, can't you? Now when you drag this down, you are getting the forecasted sales, car sales for year 5. See how nice is that? So these are the forecasted values. So from here onwards, we have been doing so much of calculation, so much of steps, so much of logic that we have carried out in order to forecast the car sales for the next year for all 4 quarters. Is it understood? But it's not yet over. Now we are going to graphically illustrate in the same chart that this particular forecasted values also, we are going to have it plotted in the same time series plot of sales. Okay. Okay, now we are going to graphically plot the forecasted values into the same time series plot of sales. Plot of sales. We'll see how it goes. So in order to plot this particular forecasted values in the same chart, go to add year forecast. Here you have to choose the forecasted values. We are not going to select until here, but also year 5 4 quarters also we are going to select. Now we'll click OK and OK. So can you all see? Look at the graph now. So here, if you want to have the year 5, also year 5 with all 5 quarters, you can always go to year and here edit. You can choose until year 5. Now all cool. Okay, look at this graph. So this orange line was the original sales, and this is the line in gray is our forecasted value. So if we had not been using the mathematical operation over here, if we had followed the same graph like this, so we would still have forecasted the values. But since we have followed a mathematical very logical process, now the forecasted values are very accurate. So it's very clear that these real values has been very close to the forecasted values. So that's the end. We now you know how to forecast. So for year 5, all 4 quarters we have forecasted. So just recall what we have been doing so far. So the first step was to we have come up with the time series plot of sales. We have visualized the data set. Then after that we have smoothened the data set. In order to smoothen the data set, we have followed this technique called moving averages technique. Since we have considered four, the 4 quarters were there now. So since we have considered four, it's an even number. So we had to again derive the centered moving averages. After that, we have taken out the seasonality and irregularity out of the sales. So you should know what each of these figures means. You should know how to interpret them, and then we have derived the seasonality. Then we have deseasonalized the data set. After that, based on the regression output, we have come up with the trend component, and based on that, we have forecasted the values by multiplying seasonality into trend. After that, we have again plotted the forecasted values to see how accurate is our forecasted values are. So I hope what we have done is clear for you. So if you are not clear about any point, you can always uh, replay the video and practice this question more often. Again, I have given you another question, so make sure. So there's an homework for you all. So you have to do this particular question and practice, because we never I'm planning to give this one of as one of your final exam questions also. So please practice makes you perfect. Thank you.